Hi everyone. So in my previous session, I've taught you about what is meant by friction, what is meant by angle of friction, types of friction, angle of repose, coefficient of friction. So a few definitions like cone of friction and all, like earlier we had seen limiting friction and all. So in this session, we are going to see about laws of friction, right? Laws. There are different laws in friction. So we shall see one by one. The first one is the friction force always acts in the direction opposite to that of body acts, or opposite to the movement of the body. You can experience friction will always be in the opposite side. So it is nothing but the definition of friction. The first point is like just like the friction is opposite to the direction of movement, and second point is the magnitude of friction. So the magnitude means the size of friction is always equal to the external force, whichever the force. For example, you are applying 10 kilonewton force, means the opposite side also you will experience 10 kilonewton force only. So the magnitude of frictional force and the external force will be equal. Okay, so the third point is the ratio of limiting friction and the normal reaction is constant. Yes, we know that coefficient of friction is equal to F by N, limiting friction by normal reaction. So it is equal to constant. That's what they are saying. And the next one is the friction force does not depends upon the area of contact. It is least bothered about the area, right? So thing is the friction does not depend upon area between the two surfaces. It depends upon only the contact surface. Okay, the friction force depends upon the roughness of the surface. Yes, I said. So if there is a roughness, the friction will be there, or else the friction will not be there. Right. So I have few examples for friction. Right. We shall see it. The first numerical is a pull of 50 Newton inclined at 30 degree. See, a pull 50 Newton is inclined at 30 degree is necessary to move a wooden block on horizontal table. If coefficient of friction is 0.20, find the weight of wooden block. So they are saying us to get the value of W, wooden block, right? So P is 50 Newton and mu is 0.2 they have said. So what you have to do immediately: vertical force, horizontal force, resolution. F cos theta, F sin theta. Horizontal cos theta, vertical sin theta. So F cos theta means the thing is force is 50 Newton. So 50 cos 30. The horizontal is 50 sin 30 over, right? So the opposite direction is frictional force F. Downfalling force is W, and towards up you can experience normal reaction N. Just place over it. Okay, so resolve. How to resolve it means, see, we know that. So here, so F is minus 50 cos 30, right? 50 cos 30. This is the opposite side of 50 cos 30. So they have got the F value equal. Okay, so mu is equal to F by N. Mu they have given 0.2. So F is, we have found 43.30 Newton divided by N. N is normal reaction. Okay, so what after resolving it, you will get N is 216.5 Newton. So like when now using the equilibrium conditions, we are just resolving it. Okay, plus N plus 50 sin 30. Okay, is it minus W, because W is in opposite side. So minus W equal to 0 or equal to W, you can plot. Okay, so using that you can get the value of W, that is 241.5 Newton. So this is how you need to find frictional answers. Okay, so the next numerical is, so the question is block A weighing 1000 Newton rest over the block B which weighs 2000 Newton as shown in the figure. Block A is tied to the wall with a horizontal string. If the coefficient of friction between A and B is 1 by 4 and between B and the floor is 1 by 3, what should be the value of P to move the block if P is horizontal and P acts 30 degree to the horizontal? So they have said that the block A is weighing 1000 Newton and block B is weighing 2000 Newton, right? So it is tied to the wall, block A. The coefficient of friction between A and B is 1 by 4 and between B and the floor is 1 by 3. What is the value of P to move the block B, to move the block B when P is horizontal and P acts 30 degrees upward to the horizontal, right? So now we need to draw FBD. So first make a separate FBD for A block and B block. Right. So this is a tensile force, mark T. Okay, away. This is just away. right? A normal reaction opposite to that of weight acting, 1000 and N1, and friction is opposite side. Likewise, for B block also, just make a figure, the forces acting this direction, so like friction will be in this direction, and 2000 Newton acting downward direction, normal opposite to that of this one, and like as I said, the frictional force will be in contact surface. So at the top you just name it as F1, and at the bottom you name it as F2. So this is how you need to draw FBD, right? So now we shall find the answers for sub question A and sub question B. Okay, so this I will continue in this lecture in the next video. Thank you everyone. Just keep watching the all the videos of this module 2. So you will be getting the continuation. Thank you everyone. Just read the question and FBD, so that in the next video I will continue my teaching. Thank you.